Question number 17 here, and we have a pair of simultaneous equations and we're being asked to solve to find both values x and y. The first decision we have to make is we have to make the coefficients of x, which is these numbers here, the numbers in front of x, or the coefficients of y, the same size. It makes no difference which you choose. Obviously there might be a slightly easier pair. I'm going to go with the x's, so I'm looking at 2 and 3 and I'm thinking the first number that I can find that they're both going to go into would be 6. So I'm going to change this equation so it starts with a 6x. To do that I'm going to have to multiply it by 3, so I'm going to make the entire equation 3 times bigger. So 2x times 3 is 6x, 3y times 3 is 9y, and 2/3 times 3 is 6/3, or I might just actually make that simple now and change that into 2 whole ones. The second equation, to turn that to have 6x at the beginning, I'm going to have to multiply by 2, so I'm going to make the whole thing 2 times bigger. So 3x times 2 is 6x, minus 4y times 2 is minus 8y, and 18 multiplied by 2 is 36. So I now have my simultaneous equations where one of the variables is the same size. The rule we now have to remember is that if the variable we've made the same has the same symbol in front of it, we're going to subtract. But if the variable we've made the same has different symbols in front of it, then we're going to add. We've made the x's the same. Here is a positive sign, it's just an imaginary one we don't need to write, and here is a positive sign we just don't need to write. So they're both positive, so they have the same symbol, so we're going to subtract one equation from the other. So I'm now going to do 6x minus 6x, well that leaves me nothing, it's eliminated. I'm going to have 9y minus 8y, so let's be really careful there. So we've got 9y, so we're starting at positive 9 on our number line, and then we're going to minus, and we know a minus and a minus actually makes a plus. So we've got 9 plus 8, so the overall effect is positive 17y, and then we've got 2 minus 36, which takes us down to minus 34 on our number line. We can now solve this using our normal balancing method. We want y, it's currently being multiplied by 17, so let's divide by 17 to get rid of that on both sides, and that tells us that y is equal to negative 2. So let's fill that in at the answer box. What we're then going to do, we could repeat the whole process, but this time we could make the y's the same size, so we could eliminate those through. Well, the easiest step I find is to substitute y back into one of the equations. Always go back into one of your originals, so I'm going to put it back into this equation here, 3x minus 4y equals 18. So I now have 3x minus 4 lots of y, which is now negative 2, and that's equal to 18. So 3x minus 4 lots of minus 2, so 4 times 2 makes 8, and a minus makes a plus, is equal to 18. And let's now solve this. So the first thing we're going to do is going to get rid of this positive 8 by subtracting it from both sides, giving us 3x is equal to 10. Let's now solve this. To get rid of this 3, we're going to have to divide because it's currently multiplying the x. And that gives us x is equal to 10 divided by 3, which is perfectly acceptable to leave, but I know most of you are going to want to turn that into what looks like a whole number and a part of a fraction remaining. So 3's into 10 go 3 times, so 3 whole ones with one of them remaining, so 3 and 1/3. And then it would always be good practice to put both of these numbers back into the other original equation that you haven't used to check that they both work.